Equations of motion by graphical method. Newton studied the motion of an object and gave a set of 3 equations of motion. These equations relate to the displacement, velocity, acceleration and time of an object moving along a straight line. An object is in motion along a straight line with initial velocity u. It attains a final velocity v in time t due to an acceleration a. Its displacement is s. Thus, the 3 equations of motion can be written as final velocity v equals to initial velocity u plus acceleration a into time t. This is the relation between velocity and time. Displacement s equals to initial velocity u into time t plus 1 upon 2 into acceleration a into time t square. This is the relation between displacement and time. Final velocity v square equals to initial velocity u square plus 2 into acceleration a into displacement s. This is the relation between displacement and velocity. Come, let us now try to obtain these equations by the graphical method. First, let us study the equation describing the relation between velocity and time. Equation for velocity-time relation. Here, the change in velocity with time of a uniformly accelerated object is shown by a velocity-time graph. The object starts moving from the point D shown in the graph. Its velocity keeps increasing and after time t, it reaches point B on the graph. The initial velocity of the object is u, that is equal to OD. The final velocity of the object is v, that is equal to OC. Time t equals to OE. Acceleration a equals to change in velocity upon time. Therefore, a equals to final velocity minus initial velocity upon time. Therefore, a equals to OC minus OD upon t. Here, OC minus OD equals to CD. Therefore, A equals to CD upon T. Therefore, CD equals to A into T. Equation 1. Now, let us draw a line parallel to y-axis passing through point B. This line will cross the x-axis in point E. Then, draw a line passing through point D parallel to x-axis. This will cross the line BE at point A. From this graph, we understand that BE equals to AB plus AE. Therefore, V equals to CD plus OD. Since AB equals to CD and AE equals to OD, V equals to AT plus U from equation 1, V equals to U plus AT. This is the first equation of motion. Now, let us study the next equation of motion. Equation for displacement-time relation. A car in uniform acceleration a covers a distance s within time t. What should be done to determine the distance covered by the car? With the help of the graph shown here, the distance covered by the object can be determined by the area of the quadrangle DOEB. Thus, distance S is equal to area of the quadrangle DOEB. S is equal to area of rectangle DOEA plus the area of the triangle DAB. Therefore, S is equal to AE into OE plus 1 upon 2 into AB into DA. But AE is equal to U, OE is equal to T, and OE is equal to DA, which is equal to T. AB is equal to A into T. Since AB is equal to CD from equation 1, therefore S is equal to U into T plus 1 upon 2 AT into T. Therefore, S is equal to UT plus 1 upon 2 AT square. This is the second equation of motion. Now, let us study one more equation of motion. Equation for displacement-velocity relation. While studying the equation for displacement-time relation, we have seen from the graph that the distance s covered by the object in time t under uniform acceleration a can be determined from the area of the quadrangle DOEB. But quadrangle DOEB is actually a trapezium. So we can find the distance covered by the object with the help of the formula used to determine the area of the trapezium. Thus, distance S is equal to the area of trapezium DOEB. Therefore, S is equal to 1 upon 2 into sum of lengths of parallel sides into distance between the parallel sides. Therefore, S is equal to 1 upon 2 into OD plus BE into OE. But OD is equal to U, BE is equal to V, and OE is equal to T. Therefore, S is equal to 1 upon 2 into U plus V into T, equation 2. But A equals to V minus U upon T. Therefore, T equals to V minus U upon A, equation 3. Therefore, S equals to 1 upon 2 into U plus V into V minus U upon A. Therefore, S equal to V plus U into V minus U upon 2A. Therefore, 2AS equals to V plus U into V minus U. Therefore, 2AS equals to V square minus U square. Therefore, V square equals to U square plus 2AS. This is the third equation of motion. Always remember, the velocity of an accelerated object changes with time. Change in the velocity can be due to a change in direction or magnitude of the velocity or both. Come, let us now understand about uniform circular motion.